Hi guys, today I would like to go over lesson 54, which is polar coordinate and similar triangles. I have the Cartesian plan and I have a few points on the board, and I think you are familiar already how to find those points of the Cartesian plan. Those are called coordinates. Let's look another way to write the same thing. Another way to write the same thing, and we're gonna use rectangle coordinates. And I'm gonna use letter I and J for that. I will mean right, then the negative I will mean left. Positive J will mean up, and negative J will mean down. The book uses, I think, R and U, but I like to use I and J more. It doesn't matter which letter you use actually. So to write the first coordinates in terms of I and J will be 3I, so 3 to the right and 4 to the left, positive 4 to the left, positive 4 to the up actually, so we will 4J. Look at point B, we're gonna have 3 to the left, so it's negative 3I because we use the negative I, and 4 up, so it's a positive J, which is 4J. Then for C, we have 3 to the left and 4 down, so that's negative 3I, negative 3J. And similar you can do for point D. Those are was rectangular coordinates. Let's look at polar coordinates. So polar coordinates we're gonna use, and let me have again the Cartesian plan. All right. So for polar we're gonna use the distance from the origin to a point. Let's assume this is 4, and the angle from the positive x-axis. And also always we're gonna go counterclockwise. So let's assume this angle is 45, and the distance to the point is 4. So you're gonna write the polar coordinates as 4 angle of 45 degrees. Or let's assume my point is in quadrant 4. Okay, so the distance, let's say it's 3, and this is 310. So I'm gonna go from here to there, it's 310. So I'm gonna have 310. All right, let's open a new board, and we're gonna convert polar coordinates to rectangle coordinates. So let's use a quick example. Let's have the Cartesian plan, and let's have a line and a point, and let's say the distance is 2, and that's 45. What you can do, you can draw a right triangle, and you're going to use sine and cosine. So sine of 45 will be equal to x, actually y, sine is usually it's related to y over 2, and then you're going to have cosine of 45 degrees will be equal to x over 2. So let's solve for y. So I got y equals to 2 sine 45, and solve for x there, we got x equals to cosine 45. All right, so y will be equal to 2 times cosine of 45, it's root 2 over 2. And same thing for cosine. So sine is root 2 over 2 and cosine is similar too. So for cosine x is going to be equal to 2 times root 2 over 2. Now I'm gonna simplify. I got y equals to root 2. In this case, they're similar, and x equals to root 2. So let's write in rectangular coordinates. I'm gonna use again j and I. So j is for y and I is for gonna be for x. So I'm gonna have root 2 I, because it's to the right, it's positive, plus root 2 j, which is up. And you are done, and that is your answer. Okay, let's look at the last part, which is similar triangles. And for the similar triangles, if you can write the sides as a proportion. If the triangles are similar, of course. If the triangles are not similar, you cannot do that. So I can see that A and D are similar, and B and C. So I can write that A over B will be equal to D over C. So you can do that only when the triangles are similar. Let's do the same. For example, if you got a similar triangle, so you got a triangle like that and another triangle that look the same. Look the same but smaller in this case. So this side over that side will be equal to this side over this side. So let's assume again this is A, that's B, that's C, and D. So you can say A divided by B will be equal to C over A. And we are done.